next step in understanding of circular motion in a vertical plane. Let's take our earlier case where the body of mass 2 kg was released from here in its horizontal position and it was oscillating like this in a vertical circle. Now we are asked, that is, what is the value of tension when it reaches over here? Let's call it as TB. That is, what is the value of tension over here? We are asked. We have understood that in circular motion, be it uniform circular motion, be it non-uniform circular motion, the velocity vector direction is always changing. When velocity vector direction is always changing, because of this change in direction of velocity, the acceleration arises. And this acceleration is called centripetal acceleration. This acceleration is called centripetal acceleration, centripetal towards center acceleration, and its value is v square upon r, and its value is v square upon r, and this is AC also, you can call it as AC also. That is, when the body is moving in a circle, be it uniform circular motion, be it non-uniform circular motion, centripetal acceleration will always be there, and this AC is equal to v square upon r, where v is the speed at that instant what we are talking about. If over here we wish to find the centripetal acceleration, we have to know the speed of the particle at this instant. If over here we have to find what is centripetal acceleration, then at this instant we should be knowing what is the speed of the particle. So one is AC. Once there is centripetal action, then certainly there has to be a force also, because force is equal to mass into acceleration. You know, all the time when the body is moving in a circle, let's say the string breaks over, this is revolving in a circle, the stone is tied to the string fixed over here, and this is moving in a circle. If this string breaks over here, this is like this, it flies off tangentially, and it flies off tangentially, it flies off tangentially. So all the time this string is always applying a force onto this block, onto this body, and pulling it inwards. It was supposed to go like this, but this string, the tension of the string, pulls it and pulls it over here. It keeps it in the path. Otherwise it would have flown tangentially. So tension is a force, or there is a force which is towards the center. Whenever there is centripetal action, it means there has to be centripetal force. Whenever a body of mass m wishes to move in a circle of radius r with the speed v or velocity v, whatsoever you say, whenever a body of mass m wishes to move in a circle of radius r with the velocity v, it demands a force. It demands a force, what we call as centripetal force towards the center, and this requirement is mv square upon r. If a body of mass m wishes to move in a circle of radius r with a velocity v, it says I need a force, net force toward the center, that is mv square upon r. If somehow someone is going to meet my requirement mv square upon r towards center, I will move in the circle, otherwise I will not move in the circle. There is going to be deviation then. Then to meet this requirement, various agencies, various forces, real forces, they come into being. Like when a stone is tied to a string and revolved in a circle, then it may be the case where the tension is providing the required centripetal force. Earth is revolving around the sun, it is revolving around the sun. Then thus, obviously when this is moving around the sun, this also is circular motion only. When this is circular motion, then there is centripetal acceleration also. When there is centripetal action, there has to be centripetal force also. From where does this centripetal force come? That is the gravitational force between sun and earth, that provides the centripetal force, and that meets its requirement of mv square upon r. So whenever there is a body of mass m wishes to move in a circle of radius r with the velocity v, it demands a force mv square upon r. If this demand is met, then this will certainly move in a circle, otherwise it will not move in a circle. Let's see what happens over here. We have seen that this body is going to move in a circle, this is moving in a circle. So it means over here, first let's find the speed or velocity of this particle at this instant. We have done it, that is, this is A, this is B. Mechanical energy, once again we can do it, mechanical energy at A is equal to mechanical energy at B. So it means potential energy at A plus kinetic energy at A is equal to potential energy at B plus kinetic energy at B. Potential energy at A is equal to mg h, that is, we have taken this as h. We can call this h as 3 meter only. This is 3, the height radius of the string is 3 meter. So mg3 plus kinetic energy is 0 because the speed over here is 0. Potential B, height from here is 0. So it is 0 plus half m v b square. So v comes out to be 2 into G into 3. Let's take it as G as 10 meter per second square for ease of calculations. So this is 20, 2 into 10, 20 into 3, that is 60. So VB over here is root 60 meter per second. If VB is root 60 meter per second and this is moving in a circle, it means it definitely have a centripetal acceleration towards center. And this centripetal acceleration is V square upon R, so we can call it as V square. V square is certainly root 60 square is 60 upon R 3, 60 upon 3, that is 20. So this is the centripetal acceleration of this body at this instant. This is accelerating toward the center. Do not say that is if this is accelerating towards the center, why it doesn't reach the center. It is always being pulled toward the center, otherwise it would have gone straight. It is because of centripetal force only that it is always accelerating towards center. It is deviating towards the center all the time. It was supposed from here to here, it was supposed to go over here, but it has been pushed. But it has been pulled in this direction. From here to here, it was supposed to go like this. It was supposed to be over here, but it has been pulled over here, so it is here. So this particle, this body which is revolving in the circle is always accelerating towards the center. If this is the net acceleration towards the center, this is acceleration, it means there has to be a force. Then what is the requirement of this force? Then centripetal force is mv square upon r. Obviously it depends on the mass m. If the mass of body, if the mass of the stone is increased, then it is difficult to maintain the same circle with the same speed. You require more tension, you require more force. If this is a lighter mass, then it is easier to revolve in a circle. So centripetal force comes out to be mv square upon r. What we have done is, it is nothing, but it is only a F is equal to ma only. Use of F is equal to ma only. This is nothing new. So this is force, this is mass, and this is acceleration. So F is equal to ma only, we are using it. So this is the net force toward the center. So we need a net force toward the center as 20. So centripetal force is, mass is 2 kg, V square upon R. We have calculated centripetal acceleration as 20. So this is 40 Newton. So centripetal force is 40 Newton. So this is the demand. This body says, I require a force, this mass of 2 kg, which is moving in a circle of radius 3 meter, which has been released from here. Then when it reaches its lowermost position, it says, I require a centripetal force of 40 Newton towards center. It says, that is now who is going to supply me that force? Who is going to meet my requirements? Then over here, we see that there are two forces now which are acting. One is tension, the other is mg. Mg will always act vertical downwards. Earth says nothing doing. Wherever you wish to go, but I am always going to apply force in the vertical direction only. Now we have taken a simple case where we are not considering the body over here, we are not considering the body over here or at any position, but a vertically downward position over here. Mg is vertically downwards and T is also, you know, that is if this is our free body, tension is always outwards. So now we have two forces. One is T toward the center, the other is mg, which is away from the center. So requirement is this, and to meet the requirement there are two forces, one is T, the other is mg. So these forces in combination, they will meet the requirement of centripetal force. Net force has to be towards center, it means T has to be greater than mg, that is T minus mg, that has to be net force, it is not mg minus T. Because the net force, centripetal force is toward the center, so that's why T should be greater than mg. So T minus mg is equal to mv square upon r. This is the equation. T minus mg is equal to mv square upon r. Now you can put the value like T minus mg. mg is 2 into g is 10 is equal to mv square upon r, that is 40. So T comes out to be 60 Newton. We get the answer. So this is a simple case we have considered where we have found the centripetal acceleration, we have found the centripetal force, and we also have found the tension in the string. Let's take another example where in the vertical circle, the point is, let's say over here at some other angle.